Hi all, welcome back to another video. Here I'm going to be talking about 12b and 12c. I'm going to talk about them together because they're really covering the same concept. And in 12b, it's one of the exercises where you should be able to sort of read it, comprehend it, and perform the questions. It is a lot of stuff that you have done before, just getting you to cover that terminology about what does a times a simplify to be, a to the power of n. The base is the number at the bottom, and that's the power, index, or exponent. There are three words that we use to describe the power. And then we have a negative base raised to an odd power. So for instance, negative 1 to the power of 3 will be negative 1. Okay, why? Because that's minus 1 times minus 1 times minus 1. So minus 1 times minus 1 is positive 1, and then times minus 1 gives you negative 1. Okay, but if you raise it to an even power, like 2 or 4 or 6, then you're always going to have an even amount of negatives, which are always going to cancel. Minus 1 times minus 1, positive 1. Okay, so that's the comment it's making there. If it's to an odd power, if you have a negative number to an odd power, it's going to be negative. If you have a negative number to an even power, it's going to be positive. Then we've got all these index laws that hopefully we're pretty familiar with. We've been using them really. I remember like we teach them in year 8. That's where I think we first get a bit of exposure to them. So we're just going to be applying them here in these 4 questions. So let's begin. We have 2 times 2 to the power of 3 times 2 to the power of 5. That simplifies to 2 to the power of 8. Okay, we've got 3. We add the powers together. Here we have 3 to the power of 7 divided by 3 to the power of 2. Okay, so that's going to become 3 to the power of 7 take 2. Okay, always the top power take the bottom power, which is 3 to the power of 5. So far we've used the first 2 index laws. Okay, when we have 3a squared, 3a in brackets and then squared, that squared needs to distribute to both of those inside the brackets. So we're going to have 3 squared a squared, which simplifies to be 9a squared. Okay, I'm going to do d down here, and then that's going to give me a bit of room to do e up there. So if I'm going to do d down here, we've got 2, I'll write the question out again, 2b to the 4 on a to the power of 3. So that power of 3 is going to distribute to every single thing in the brackets here. So it's going to distribute to the 2, it's going to distribute to the b to the power of 4, and it's going to distribute to the a at the bottom. First, let's concentrate on the 2 and the a at the bottom. That's all fine. But when you have b to the 4, so now we're going to be using this index law here. Okay, see how we've got b to the 4 and then the 3 out there? So that 3 and 4 are going to multiply one another. And so at the top here, we're going to have b to the 12. And so in simplest terms, 2 to the power of 3 is 8. So we've got 8b to the 12 on top of a to the power of 3. Okay, so that's the answer for D. Let's have a look at E. Okay, again, that 4 is going to distribute to every term. So we have minus 3 to the power of 4. So here's question E. Draw a line there. Minus 3 to the power of 4. We've got a to the power of 8. We know the 2 and the 4 are going to multiply, and then b to the power of 4. And minus 3 to the power of 4 is minus 3 times minus 3 times minus 3 times minus 3. Because it's an even number, the answer is going to be positive, and 3 to the power of 4 is 81. So we've got 81, a to the 8, b to the 4. Let's move on to question 2. We have express as a single power of 2. So 4, we can write that as 2 to the power of 2. Okay, so here, like with these questions, it's very helpful to know your powers for the first sort of 4 or 5 prime numbers. Okay, so for instance, 2 goes 2, 4, if I'm talking about powers of 2, 2, 4, 8, 16, 32, 64. 3 goes 3, 9, 27, 81, 243, etc. It's useful to know these. Okay, so here we are, 1 on 9. What that's going to be 1 on 3 squared. And it wants us to write it as a single power of 3. So that one way we can express that, okay, is using this index law here, the negative index law. If we have it expressed at the bottom as a fraction, we can, the bottom of a fraction as a power, we can move it to the top and make the power negative. So that's what we're going to do here. We're going to express this as 3 to the power of minus 2. 3 to the power of minus 2 is 1 on 9. Okay, 5 times 25 to the power of a. Now this one's going to be 5 times 5 to the power of 2 to the power of a. 25 is 5 squared. So that's 5 times 5 to the power of 2a. Okay, that distributes. And then we have the same base, 5 and 5. And so we're going to add these powers together. Now 5 by itself has a power of 1. So what this is going to be is 5 to the power of 1 plus 2a. Okay, so that one there is all fine. All right, in this example, we've got 4 to the n plus 1 on 2 to the x. So that's going to be 2 to the power of 2 to the power of n plus 1 at the top, and we have 2 to the x at the bottom. So that 2 is going to multiply both of these powers outside the front there. So what we've got then, we've got 2 to the power of 2n plus 2 on top of 2 to the x. Here we have the same base, which means we're going to do the top power, take the bottom power. This simplifies to 2 to the power of 2n plus 2, take away x. Okay, so we express that as power of 2. We distributed that power. And then we recognize we've got the same base. So top power, take the bottom power. That's our second index law. Okay, write in non-fractional form. That means write with negative indices. So here what we've got, I'll show you with this one exactly what we're doing when we're writing without negative indices. We've got 3 on top of a to the power of x. Now we could write that as 3 times 1 on a to the power of x. And as we've seen, the rule is if you have a negative power at the bottom, if you have a power at the bottom, you can move it to the top and make it negative. Okay, so here we're going to move that to the top and make it negative. And that's our answer, 3 times a to the minus x. So we have gotten rid of the fraction completely. Okay, let's have a go at this one. We've got x plus 3 on x squared. This one, we don't need to change this term at all. That's just going to hang out there. So we've got x, but 3 on x squared becomes 3 times x to the minus 2. Okay, the 3 hangs out there, and we've got 1 on x squared. We move the x to the minus 2 to the top. We move the 2 to the top, make it negative because we're bringing it to the top of the fraction. Okay, a on top of b to the minus m. This is going to be a, b to the positive m. So at the bottom right, it's got a negative power. So when we move it to the top, it becomes negative m, which becomes positive m. Okay, write without negative indices. So that means we may have to shuffle things around a bit here, depending on what side of the fraction they're on. We've got a to the minus 4. We can write that as 1 on a to the top of 1 on a to the power of 4. 3a to the minus 2. Now be careful here. Okay, notice there are not brackets around the 3 and the a. That the negative 2 only applies to the a term. So that means 3 is going to hang out at the top, and we're going to have a squared at the bottom. Okay, very, very similar to the example we did over here. All right, we've got a to the minus 4 on b to the minus 3. So what that means we need to do, we need to put the a at the bottom. So we've got a to the 4 at the bottom, and the b we're going to bring to the top, aren't we? b to the power of 3. So what you're doing is you're swapping its position on the fraction and changing the power from negative to positive. So there's a good introduction or recap of index laws. Hopefully some of those processes are pretty familiar. Good luck with it.